All right, let's go ahead and work through the last part of this review. We have allicin is the compound responsible for the characteristic smell of garlic. An analysis of the compound gives the following percent composition. What's the empirical formula? Okay, now my first step is always assume that I have 100 grams so that my percents become masses. So in this case, I have 44.4 grams of carbon, and I have 6.21 grams of hydrogen and 39.5 grams of sulfur and 9.86 grams of oxygen. I want to convert each of these to moles. So I use their molar mass. Carbon, 1 mole of carbon is 12.01 grams. Hydrogen, 1 mole of hydrogen is 1.008 grams. For sulfur, right, 1 mole of sulfur is 32.07 grams. And oxygen, right, 1 mole of oxygen is 16 grams. Okay, so let's plug that in my calculator. 44.4 divided by 12.01, right, that's 3.70 moles, once I round that, of carbon. And then 6.21 divided by 1.008 is 6.16 mole of hydrogen. 39.5 divided by 32.07, right? That is 1.23 moles of sulfur, and 9.86 divided by 16 equals 0.61, around that 62 moles of oxygen. So then what I want to do with all of these is make a formula. C3.70, hydrogen 6.16, sulfur 1.23, and oxygen 0.62. All right, now the oxygen is my lowest one, so I'm going to divide all of the numbers here by the smallest one. So 0.62, 0.62, 0.62, and 0.62. I know this is going to be 1, right? 1.23 divided by 0.62, right? This reduces to 2, right? 1.98 is very close to 2. 6.16 divided by 0.62 is 9.93. We're going to round that up to 10. And then 3.7 divided by 0.62 is 6. So this reduces to 6. So C6, H10, S2O is my empirical formula for allicin. All right. The same process applies here. Okay, after running a sample from an oil-contaminated beach, it's found that a compound present contains these percentages, which is abnormal. Okay, what's the empirical formula for this compound, right? We have an oil-contaminated beach, we don't want it. This is something we don't want, but here we have these percentages, right? 85.7 grams of carbon, right? I assume that I have 100 grams so that my grams convert easy to masses and convert to moles. 1 mole of carbon is 12.01 grams, right? 14.3 grams of hydrogen times 1 mole of hydrogen is 1.008 grams. And I convert those. 85.7 divided by 12.01. That is 7.14 moles of carbon. Let's see. Got my decimal there. 14.3 divided by 1.008 is 14 moles of hydrogen, right? So C, 7.14, and H, 14 divided by the smallest, 7.14, 7.14. This is 1 and this is 2, right? So my empirical formula is CH2. Okay? That is my empirical formula there. Okay? Now, I'm going to have to come back to these in just a little bit. Okay? So, uranium is naturally found as uranium oxide, where 84.7 is uranium and the remainder is oxygen. Okay, what do you do in this situation? I've only given one of my percentages. Well, I'm told the only other thing is oxygen, and the total has to be 100%, right? So, 100 minus 84.7 equals the amount that's oxygen, right? So 100 minus 84.7 is 15.3, right? So 15.3% oxygen. So now I can do the math, right? 84.7 grams of uranium times 1 mole of uranium weighs, all right, let's look that up because I don't have that one memorized. Uranium, here it is, 238. 238.0 grams. Right? And oxygen, I have 15.3 grams of oxygen. 1 mole of oxygen is 16 grams. Okay? So let's do my math here. 84.7 divided by 238.0, 0.36 moles of uranium, and 15.3 divided by 16 is 0.97 moles of oxygen. All right, so I write my formula using those moles. U 0.36 and O 0.97. This is the smallest one, so I divide them both by the smallest one, 0.36, 0.36, right? This reduces to 1, 0.97 divided by 0.36 gives me 2.69, which is very close to 2.66. So I'm going to multiply both of those by 3 to get rid of the 1/3 that's part of the 2/3 that is. Okay, so 2.69 times 3 is 8. All right, so I have U3O8 is my empirical formula. All right. Okay. Allicin is a compound, blah, blah, blah. We get this. If the molar mass is this, what's the molecular formula? Right? Well, I need the empirical formula from that, so I have to go back to my previous page. Right? Allicin, that's number 16 here. C6H10S2O. Okay? This is my empirical formula. Right? How much does that weigh? Right? Let's write it all out here. 12.01 times 6, 1.008 times 10, 32.07 times 2, and 16 times 1, and add all that up. Okay, 12.01 times 6 plus 1.008 times 10 plus 32.07 times 2 plus 16, 162.28 grams per mole. Right? Well, we're told that the molecular formula, the molar mass, is 162. 162 grams per mole over 162 grams per mole equals 1. Therefore, C6H10S2O is the molecular formula. All right, so it's already the same thing. So the empirical formula and the molecular formula are equal to each other in this case. All right, so we have the sample from the beach. We have its molar mass. What's its molecular formula? All right, well, if we look back here at this page, we found that the oil from the beach is CH2. So we'll transfer that there. CH2 is 12.01 plus 1.008, 1.008, right? Add those up. So this is going to be 8 and 8 is 16. Carry the 1, 2, 0, 4, 1, 14.026 grams per mole. Okay. My molar mass is 84.0 grams per mole divided by my empirical formula mass, 14.03 grams per mole. All right, let's see what that gives us. 84.0 divided by 14.03, that gets me 6, right? That means I have C1 times 6 H2 times 6, so C6H12 is my molecular formula. Okay. And finally, uranium here, we found this. What's its molecular formula if it's 286.03? Okay. Well, let's pull up this here. Here we go. I think we're going to have a problem with this one. All right. Perhaps shouldn't have done this. Okay, and this tells me that if this problem is correct here, if it's 286, then I should not have done this. My 2.7 here should not have been rounded. So I want to go back and change this. This should be UO3, right, is my molecular formula, or sorry, my empirical formula, right, because this 2.67 shouldn't have been rounded. I know that offhand because of this mass. Okay. Remember, here my uranium, okay, my uranium is 238, right? 286, right? Well, let's see. If I have UO3, then I have 16 times 3 grams per mole for the oxygen, right? 238 plus 16 times 3 is 286. 286 grams per mole. And so once again, my molecular formula, is equal to my empirical formula, which is UO3. Okay, because 286 divided by 286 equals 1, right? 1 from there, 1 from there, equals 1, so they are the same. Right? These are the same. And that's your review. So if you have questions, feel free to shoot me an email, send me a thing on Schoology or whatever you need. That is the end of your review. Good luck.